Today's lesson is going to move on from solving algebraic equations that were written for you to solving algebraic equations that you will have written, so linear equations specifically. So the first thing we're going to do is learn how to translate from words to mathematical expressions. So this is kind of the warm-up. It's learning what words are associated with what operation. So for example, we're going to be looking at the words associated to addition, subtraction, multiplication, and division. So when the operation is addition, you'll see words like sum, or more than, or plus, or added to, or increased by. Sum is the answer of an addition question. So we'll start with the sum of a number and 7. Anytime you see the word unnumber, that means your variable. That's your unknown. So you can use the variable x, you could use the variable n, you could use the variable p, you can use whatever you want. So the sum of a number and 7 is x plus 7. The next question says 6 more than a number. Now these ones are tricky because in addition it's not such a big deal. With subtraction, this than word is going to be more of a big deal. But technically this is an action. So it's 6 more than a number, which should technically be written as x plus 6 because it's 6 more than a number. Which again with addition, because you can do the commutative property of addition, if it was 6 plus 7 or 6 plus x, it would work. But from this phrase, you should be writing it as 6 more than a number, which would be x. The next one is 3 plus a number, which would just be 3 plus x. The next one is 24 added to. So this is that same action, right? More than, added to. So you're going to have a number plus 24. This is 24 added to a number. Versus a number increased by 5 would be any number increased by 5. And then lastly, the sum of two numbers means you have two variables, so something like x plus y. Words that signify subtraction are less than, just less, minus, decreased by, subtracted from, and then the difference of. So again, the only thing you're looking for is anything that's an action word. So that less than or that decreased, well, decreased by wouldn't work, but subtracted from. The than and the from are the key words that order is going to be a little bit different. So this one, when it says 2 less than a number, it's a number less 2. And I've switched to the variable n. It doesn't matter what variable you use, but the key thing, this one is 2 less than a number. And the only way to write that is like that. If you want it to be 2 less a number, they won't say the word than. And these are two very different answers depending upon which one you write. The next one, 12 minus a number. The next one, a number is getting decreased by 12. This one, a number is getting subtracted from 10. So to subtract a number from 10, it must be written second, versus 10 is subtracted from a number. Again, that action word makes it come second. And then lastly, a difference of two numbers. Difference is the answer of a subtraction question. So it's just two numbers being subtracted. The next two operations are multiplication and division. So multiplication, you're looking for words like times or multiplied by or of or as much or twice or triple, or product. Product is the answer of a multiplication question. So 16 times a number multiplied by 6. My variables keep going away, that's weird. Now this one, it says a number multiplied by 6, but you will never actually see it written like that. You will often see the number written first, followed by the variable. And again, that order thing, right? Commutative property of multiplication, it doesn't matter whether you have a number times 6 or 6 times a number. It'll be the same, but when we do division, that'll be a little bit different. But just standard, like if you wrote this on a test, I'd be totally fine with it. You could also write n bracket 6. You could do n multiplied by 6. Watch your multiplication symbols because they look like x's. But ideally, you'd write it like that. 2/3 of a number could look like this. 3/4 as much of a number could look like that. Twice a number, triple a number, or the product of two numbers. And again, I'm switching between n's and x's. It doesn't really matter. I like to choose variables Like if I know that I'm going to be solving for a number, I'll use an n. If it says an unknown, I have to use x, but it really doesn't matter what variable you use. I'll start switching back to x's. So the quotient is the answer of a division question of a number, or 8 and a number. A number divided by 13. Now this is a tricky one. Here's an action. 13 is getting divided into a number. A ratio of two numbers is just a division, and a quotient of two numbers is the answer of a division question. Now you'll see I have a double star down here, and it says watch restrictions. Don't worry about that too much right now. We're going to be dealing with restrictions when we get to chapter 6, but I just want to explain that in your textbook, sometimes they will also include something like this. And what that means is that as soon as you have a variable in the denominator, you should be specifying that your variable cannot equal 0. Because if you divide by 0, you're undefined. So anywhere where I ended up writing a variable in the denominator, I should put a restriction. You do not need to, but I just want to explain why your textbook is doing that. All right. Now what we're going to do is move on from phrases to equations, or phrases into sentences, and we're going to be going into equality. So the key thing is that anytime you see the word is means equals. I'm not too sure why my computer screen keeps doing that, sorry. Is means equals. And so what you're going to look at is anytime you see the word is in an equation, you're going to put an equal sign. So let's read these sentences and see if we can figure out what the operations will be. This says the sum, so we know we're talking about addition, of a number, let's say x, because it said use x as the variable, and 6 is 28. So what does that mean? So the answer of an addition between x and 6 is 28. And that's an equation that we will be able to solve. The next one says the product. Product means that we're going to be using multiplication. So the product of, again, a number, which we're going to use x, and 7, and there's that word is, twice that same number plus 12. So notice how I've taken the words and just written the symbols above them, and then I'm going to clean it up a bit. So the product of a number and 7 means that 7 and x are going to get multiplied, is 2 times that number, or twice the number, plus 12. And there's my equation that I could solve. And what we'd be solving for is the number that makes that equation true. All right, hopefully you're learning to pause the video when you want to try one. This would be a good chance to do that. Quotient is a division. So the quotient of a number and 6 added to, and there's that action word. So this is going to be added to, this thing is going to be added to twice the number, and the answer is going to be 7. So how do we do this? We've got the quotient of a number and 6. It's going to get added to. It's going to be the action, and it's going to get added to twice the number, and the answer is 7. All right. So before we can start going into solving, I want to make it really clear what the difference between an expression and an equation is. An expression is just a phrase. The only thing that can be done is simplify it. You cannot solve expressions. You can input variables in, so you could substitute variables into an expression, but you cannot solve an expression. The next thing is an equation. An equation includes an equality symbol. There'll be expressions on both sides, and it'll translate as a full sentence and can be solved. So when you're looking at two possibilities and you have to decide which one's an expression and which one's an equation, the easy thing to do is that if it's an equation, you're going to see an equal sign. So this one is your equation, and when it says decide what it is, make sure you put down which one it is, or you're going to lose that mark on a test. So this first one is your equation, the second one is your expression. So the equation we're going to solve, and the expression we're going to simplify. So when you're solving an equation, the first thing you want to do is actually simplify it. Okay, so we're going to distribute this -3 through. You get 5x. -3 times x is -3x. -3 times 2 is -6 equals 7. And then we're going to collect like terms to simplify further. So we get 2x minus 6 equals 7. And then we're trying to solve for x. We're trying to isolate x. So the first thing we're going to do is the inverse operation of subtracting 6, which is adding 6, so that we get 0. What you do to one side, you have to also do to the other. you end up with 2x is equal to 13. And then to get x by itself, the 2 and the x are multiplying, so the inverse operation is dividing. What you do to one side, you do to the other, and you get 13 halves. Now, a lot of people get confused when they get a fraction as an answer. It's okay to answer as 13 halves. That's a simplified fraction. You could also answer as 6.5. You could also answer as 6 1/2. Those are all fine. The rule of thumb is that if the question has a fraction, make sure you answer as a fraction. If the question isn't a fraction, if your answer is a nice terminating decimal, feel free to write it. If it's repeating, you're probably going to have to keep it as a fraction. All right, moving over to the expression. So this one's the expression instead of the equation, so all we can do is simplify it. So we're going to do the brackets first. We're going to distribute that -3. So we're going to have the 5x is going to stay out front. -3 times x is -3x. This is an equal sign here. -3 times 2 is -6. And then you've got this +7 on the end. Then we're going to collect like terms. You end up with 2x plus 1. So the answer to the equation is a solution. It's x equals 6 1/2, right? Or 6.5 or 3 halves. And this is what you could put back into the equation to check to make sure you got the right solution. With an expression, you'll notice that there was no equal sign to start, so we put one on the left, and we're saying that this phrase has the same value as this phrase, which has the same value as this phrase, and it's just a simplified expression. There's no value of x that will make it true. All right, go practice that on your homework and come watch the next video.